Hello everyone, my name is Haewon Shin. I am working on VMware Tanju team and helping customers on their journey to modernize their applications. And as a CTO ambassador for Office of the CTO in VMware, I am helping to ensure a tight collaboration between R&D and our customers so that we can address current customer issues and current future needs as effectively as possible. Today, what I'm going to say is about how VMware Tanju application platform helps you secure your applications. In this session, I will look at problems that can arise from a security perspective and the process of deploying and managing applications, and how Tanju application platform can solve these problems. In general, I have selected 5 security issues that can occur in the process of developing and deploying applications. First, one of you who are watching this webinar right now may have experience in developing applications without considering security, and then having hard time meeting security requirements right before system launch. If these things can be guided to developers from the beginning rather than right before system launch, it will be possible to create secure applications easily. In this way, we will look at how to apply corporate security standards to your applications. Second, when you create a path from code creation to deployment on production environment, I mean path to production, we will consider how we can do automated security and compliance checks to all application pipelines. Third, you need to containerize your applications after developing it. We will consider how we can create secure app containers. And there are cases where applications will be running on various multi-cloud environments. At this point, we will also think about how you can deploy applications using a consistent and secure process to different Kubernetes environments. Finally, we will talk about how to enforce and manage security policies across many Kubernetes clusters from different vendors on multiple cloud providers. Tanju application platform is abbreviated as TAP, as taking the first letter. We call this TAP or TAP. We can see the definition here. This can be run on any Kubernetes, not only our VMware's Kubernetes platform called Tanju Kubernetes Grid, in short TKG. Here, modular means that when Tanju application platform is installed, not all components are installed, but only necessary components can be installed so that the components are provided as modules. As mentioned earlier, Tanju application platform runs not only on VMware's Kubernetes TKG, but also on public clouds such as Microsoft AKS, AWS CKS, Google's GKE, Vanilla Kubernetes, and even Red Hat OpenShift. In other words, it can be installed and run on top of any Kubernetes that is comparable with open source Kubernetes. There are 3 main advantages of using Tanju application platform. First, it is bundled with functions that can replace unnecessary tasks other than development so that developers can focus on coding. This improves development productivity. Second, when you create a workload based on source code, it automatically creates a pipeline to create a fast and sustainable path to production. Finally, coordinating the developer's code tasks and the operator's deployment tasks is the main role and advantage of Tanju application platform. A few months ago, I had a webinar titled "An Efficient Way to Your Kubernetes-Based App Development Productivity." It was a webinar that overall explained the functions of Tanju application platform, and please refer to this webinar for the general overview. You can access it by scanning the QR code shown here. Today, I'm going to cover the session through demonstrations. Before explaining this demo environment, I'd like to introduce a concept of profile Tanzu application platform includes. When I explained Tanzu application platform earlier, I used the word modular. Tanzu application platform provides profiles by grouping necessary capabilities for each role in a modular way. There are 5 profiles provided, such as iterator, view, build, run, and full. For example, a build profile is a profile that gathers capabilities required for building images in Tanzu application platform, and a full profile is a profile that includes all capabilities. I will shortly explain the demo environment that we will be using in this webinar. It consists of 4 clusters called iterate cluster, view cluster, build cluster, and run cluster. Depending on the role of the cluster, these clusters were named according to the profile name explained earlier. We say the concept of inner loop and outer loop together when explaining Tanzu application platform. The inner loop means that the developer starts development repeatedly to cause, debugs, and commits the final source to the source repository. The inner loop, the iterate cluster is a cluster where developers can build and debug their source in this process. The build cluster is a cluster responsible for building applications. When developers commit the source code, the supply chain for the application is automatically created, and an image is created by building the source and pushed it to the image registry. Then the run cluster pulls the image stored in the image registry and runs the container on it. There is only one run cluster in the demo environment, but you can have multiple run clusters if you want to configure it in multi-cloud or multi-cluster. Of course, you can specify the cluster name arbitrarily. The view cluster is a cluster where Tanzu application platform GUI installed. You can check information such as monitoring and supply chain for applications running in each cluster on this GUI. Of course, you can also have a single cluster handle everything by using the full profile. If the number of applications you need to deploy is small, you can do this. However, it is recommended to divide clusters so that it can scale according to each functions if applications gradually increase. In other words, in case that resources are insufficient while supply chain runs, the build cluster need to be scaled. Developers code in an IDE tool, debug it in an iterate cluster, commits the complete source to the source repository. The build cluster then detects the changed code and starts a build. The build cluster includes an out-of-the-box supply chain, which can be built and deployed on this, or can include additional functions such as source testing or image scanning, and the completely secure image is stored in the image registry. Run cluster triggers the image registry, and when the changed image is detected, it pulls a new image and runs the application. There is a UI portal, Tanzu application platform GUI running on view cluster. It manages running application supply chain for app deployment, scanning images, and source templates. That is, it is responsible for lifecycle management related to deploy applications. Now, Let's look at how to solve the security issue mentioned earlier with Tanjo application platform configured in the demo environment. Let's remind the facing security problems. I will suggest a solution for each issue. First, how to help developers design and implement secure applications following corporate standards. We need to provide standard templates for codes when starting a project or when a new developers join. Standardizing and managing sources is a very important part of the code development. Developers who have experience in developing with Spring Boot will be familiar with this page. We call it Spring Initializer. Usually, when you start developing a Spring Boot-based applications, you choose a tool, language, boot version, project metadata, packaging type, Java version, etc. to build on this page. And choose the libraries you want to use this way. I will add 2 libraries, Spring Web and Actuator, like this way. And I will leave the other options with the default values. And click the generate button to download this application template as a zip file and start developing based on this. You can download this the source from the web and import it in the IDE tool. But these days, most IDE tool provide plugins that allows direct import. In this session, I'm going to use Visual Studio Code as an IDE tool. It also supports the Spring Initializer plugin. Let's execute the Spring Initializer plugin and create a project. Spring Boot version, Java, group ID, artifact ID, packaging type, Java version, and I will use the libraries as what I've last used, Spring Web and Spring Boot Spring Boot Actuator. And if you specify a directory and click the generate into this folder button and click project you just created will be imported like this way. Libraries added here will be mainly used as a corporate standard. Once you save source template in the specific location in this way, you can control it at the initial stage whenever new developers join the project. Now, I'm gonna try to make this source as a template. These source templates are called accelerators in Tanjo application platform. When Tanjo application platform is installed, about 10 more accelerators are registered by default. Here is the accelerator list, and I will add it to this list so that developers can refer to this source template. In order for this source to be recognized as a template that developers can use in Tanjo application platform, you have to create the accelerator YAML file in the project directory. So I will create an accelerator YAML file, accelerator.yaml file created. And so this file contains accelerators information such as accelerator's name, description, and tag information, etc. So I'm gonna add this sample source created to this source repository. Here I'm gonna use GitHub to save. Click this button, source control, and click the publish to GitHub button. And I will create the repository as a public repository. And second one, click second one. It is publishing and successfully published. Well, so let's check it if it is successfully published. Open on this GitHub repository. So yeah, it is just created and commit. It was published well. And now let's register the accelerator using Tanju CLI. You can register using CLI with Plex or through YAML file. I will register through YAML file. So let's check the accelerator manifest YAML file here. The accelerator's YAML file, accelerator's name is simple. You can see this name. And it is a file configured to refer to the previously saved GitHub location and branches. I've already made this file accelerator manifest YAML file, and let's register accelerator using Tanju CLI. Kubernetes context must be pointing to view cluster. Let's change the context to view cluster. Okay, before applying it in, let's check if a simple accelerator already exists because its name is simple. So Tanju accelerator get simple. So there's no simple accelerator. So we've checked it does not exist here, and let's create a simple accelerator. Tanju accelerator apply -f accelerator manifest YAML. So it is just created. You can check the registered accelerator through the CLI like this way. Tanju accelerator list here, and you can find the simple accelerator and Tanju accelerator get simple. It exists. So or you can check it in the tab plugin installed in the IDE. You can click the Tanju application accelerator with the Tanju icon like this way, and you can see the simple accelerator here. Also, you can check the simple accelerator has been added in the same way in the Tanju application platform GUI. So you can see here, and simple accelerator exists here. In this way, it can help to design and implement Kubernetes-based secure applications by providing secure application source templates, accelerator, that enterprise will use as internal standard. Second, how to add and maintain automated security and compliance checks to all application pipelines. Tanju application platform provides functions that trigger committing the source code to build a source, create an image, and deploy the applications to Kubernetes platform. Let's create an application using the Git URL where the source was pushed previously. First, let's create a workload file to deploy the application. It is common to include this workload file in a template, but I will do it now since we didn't edit it earlier. So now I will deploy this application as a workload. Workload YAML file is needed to create the workload. Or you can use Tanzu CLI with this with the flags. First, I will create the workload YAML file here. Workload.yaml file here. So this is workload YAML file. This file means a simple -demo workload. GitHub location is here. GitHub location is here and branch is here. It is pointing to the source location I created earlier. Applying a workload must be executed in the build cluster. So let's change it to the build cluster. Config context build cluster here. Okay, now let's create a workload using Tanzu CLI like this. Tanzu apps workload apply YAML. Wait a while and workload is created, and then a pipeline for this workload is created with just this command without the process of creating and deploying an application separately. You can check the log of workload created just now with this command. Tanzu apps workload tail this. It is executing to build source file now, and let's check this pipeline in the tab GUI. So let's check if it is created. Yes, it is creating now. Simple demo is created. This pipeline is called supply chain in Tanzu application platform. And when a workload is created, the created supply chain can be checked in the tab GUI. I use the out-of-the-box built-in supply chain to test source and scan images in the demo environment. Let's see the order in which this supply chain works. First, it tests that there are no errors in the source, and then the source file itself is scanned for security violations. After that, the image is created in the image provider step. After scanning the image, Tanzu application platform pushes it to the image registry and configures the cluster to deploy the application. Once it's completed successfully, the green check icon will be displayed in the upper right corner inside each step box like this. So some of steps are successfully done. So you can see some of green check icon here. And the config writer is at the end. We have to do one important thing to deploy workload on run cluster. So actually there is the process of a process in the build cluster. There's no process in the run cluster. After creating the workload, the build cluster performs several tasks for deploying the applications, such as building source and creating the image and pushes it to the image registry. Since these workloads can be deployed to multiple clusters, you have to create a deliverable file that refers to images which were created and pushed from build cluster. The deliverable file is stored in the config map in the build cluster, and you can obtain it using the following command. So let's take it. K-n developers get config map simple demo deliverable. Sorry. Okay. Deliverable stored in config map specifies repository secret for GitOps here. Repository address and subpath here. Subpath location in repository where deliverable YAML file is located. As a default, subpath location is configured as workload name under the developer namespace under config in this case. If you have acquired the YAML file for deliverable by copying this, you need to apply it to the run cluster. So, okay, config use context run cluster. So, here, so we can apply this deliverable YAML file like this way. So K-n developer namespace. I made it made the namespace or with the environment. So apply, let's say deliverable. Yes. So deliverable file resource is created on the run cluster. Okay, so let's take it. Okay, it is refreshed and full config and delivery box was just created. Now let's check if the supply chain has changed again. So we saw it. So we see that something should be shown after the config writer, but it is already appeared. We saw it. If we check the pipeline for deployed application running on cluster, we can see that there is two boxes behind the config writer, like this way. The processes after this work on the run cluster. If you look at the bottom right corner of the config writer box here, there is an arrow mark. If you configure GitOps, this mark will appear. After configuring this, you must go to the corresponding GitOps repository and approve it before proceeding to the next step. I will come back to this point later. If you don't configure GitOps, the deployment will happen right away, and an arrow mark will an arrow mark on this config writer configurator box will not appear as well. In the pull config step, an image is pulled from the repository where the image is stored. Like this way, a container is created and the application is deployed. It works on the build cluster before pull config step, and it works on the run cluster of the demo environment described earlier after pull config step. The supply chain works in this order. If an error occurs in a specific processes, the supply chain stops moving to the next step and indicates an error. Among this chain, there are a source scanner and image scanner, which check whether there are vulnerabilities in the source and image. For example, the scan policy is applied by the source scanner. Scanner is named scan-policy, and the policy is applied as follows. So is the scan policy applied by the image scanner. In case of critical, it is also configured to pass. So that's why it shows the green mark. But if you wanna create critical case to be configured not to pass, an error occurs. These policies are OPA-based, Open Policy Agent. The Open Policy Agent is an open policy, open source. The Open Policy Agent is an open source, general purpose policy engine that unifies policy enforcement across the stack. Now, we can see vulnerabilities here. I will modify this scan policy. This scan policy is located in the build cluster, so I will change it to the build cluster. I will modify this scan policy so that these critical vulnerabilities are not allowed, since this source code contains critical cases. Now let's modify those policy of scan-policy. Okay, -n developers edit that scan policy. Yes, this is there is here. Edit scan policy. So I will modify it to the not to pass the critical case, like this way. Yes, so I edited it. So if you wait for a while, you can see that the supply chain is running and generating errors in the source scanner step. So we the original configuration was not to allow only unknown security, right? Unknown severity. So since the policy is changed, it will change here too. So if the error found that this process is returns error, and you can see the error red mark here. While waiting, let's check the applied scan policy. So, oh yes, here you can see the red mark successfully. Red mark red arrow mark appears in the source scanner box. And you can see there an error has occurred, and let's click and see the scan policy if it's changed. So click here and it is changed. So yeah, right. And the vulnerabilities result of all workloads running on Tanzu application platform can be displayed on a single view like this. It is divided. So I will show you. So yeah, here, so like this way, violates policy and does not violate policy, no associated policy. It is divided into list of vulnerabilities that violate policy, vulnerabilities that did not violate policy and are not associated. As for the vulnerabilities that do not violate the policy, they are displayed briefly according to labels such as critical, high, medium, low, and unknown for each workload. Hovering your mouse over these labels display the number of vulnerabilities checked for each label. In this way, it can be easily and safely managed since these scan policies are applied errors in all supply chains that use this scan policy. I will restore this scan policy for the next step. Okay, -n, edit. Okay, let's check it again. Okay, it is changed. Next, third, how to make sure that developers are containerizing applications securely. The most common way we usually use to create an image to run on Kubernetes from source is to create a Docker file. Docker files are structured this way. I will show you. So I will create the Docker file. So yeah, Docker file should be like this way. Which is a way of scripting from a default base image. This is default image location, and this is scripting areas. If security vulnerabilities are found, the base image must be replaced, like changing, or script part must be modified, and the image must be rebuilt. All images must be rebuilt. This process means that there is an issue that you have to open the Docker file one by one to check which image is used to rebuild the entire image being managed. I mean, there's no way to check and manage which images are used in the Docker files at once. Tanzu application platform, here. Tanzu application platform includes a module that creates an image called build service internally. Here. There is an image provider supply chain that is automatically created when deploying the applications. In this part, source repository is detected and an image is automatically created when the source code is changed. You can see the list below. One build has occurred, so I just click it. If you look at the most recent build log, you can check the log. The image was rebuilt. You can check the log that the image was built by the build service. There is something called Cloud Native Build Pack inside this build service. like this way. It includes various build packs for each languages that and it plays a role in building an image by choosing a build pack suitable for the source automatically. For example, this code is source implemented in Java. There is a build pack listed there necessary here, past unnecessary ones like this. And bring the necessary build packs. In addition, it stores reusable images from metadata in this way to improve performance. Because it builds images based on source code, you can build images without creating Docker file. A build pack creates an image by combining several images. You can use KPack CLI to query build pack information or create an image. KPack is a Kubernetes native platform maintained by VMware under the VMware Tanzu project that utilize unprivileged Kubernetes primitives to provide build of OCI images as a platform implementation of cloud native build packs. As shown here, you can see the list of stacks installed in the Tanzu application platform. Here is a cluster stack list. You can retrieve the same information of these stacks using kubectl CLI. Okay. Clusters. Okay. Yeah, like this way. The stack includes libraries, etc. Used in OS. So let's check it. Cluster stack default to. So like this way. So several libraries are here. So you can just use this cluster stack. And you can check the libraries as in this way, and you can check the cluster store information in the same way. Okay, cluster store. So you can check the store like this way. So similar, there are some of build packs are here. So it includes several libraries related to the language used in the source code. In this way, the build service creates an image by combining the cluster stack image, cluster store image, and source. This is done by the build pod. Let's check it. And developers or namespace get pod. So there are some of the paths here, and whenever a build is performed, the number container, let's check it. There is only one build path for simple demo applications. Whenever a build is performed, the number contained in build path name increases and build history is managed. For example, there are only one build pod here, so I cannot show you. You can check. You can also check the pod log to see how the build went. So logs simple. Yeah, like this way. So similar log file is shown here. Because the single image is created by gathering several necessary images, you just patch the corresponding image if image update is required for reasons such as a vulnerable image being found. In that case, the build service will automatically rebuild the application images using the changed image. You can manage your secure images because you don't have to rebuild them manually one by one. Fourth, it is a way to deploy secure images created safely. As I mentioned earlier, you can control application deployment by adding an approval process before deploying the application to the supply chain. In this demo environment, GitHub is used for approval management with GitOps way. Now let's check GitOps repository. Click here, refresh here, so you can see the number 1 here. Click the pull config request button here. Tap. In the GitHub repository, the delivery YAML file is created in the workload name in the namespace name in the config directory. So let's check the let's take the delivery YAML file for other applications. For example, Tanju Java web app application has already deployed on the run cluster, so deliverable YAML file exists like this way. But simple demo application, for simple demo application, I didn't approve yet, so it cannot be created yet. So this file is automatically created, and the important thing is to check here is the location of the image in the container. Whenever source is changed, the build service is the build service in the build cluster builds the changed source, creates a new image, pushes it into the image registry, and creates a new branch in GitHub. Okay, now I will click the ready for review, and I approved merge pull request. Confirm, just confirm. And now it is created. It is just created. So you see now here, and delivery YAML file shown here. And as I already mentioned, whenever source is changed, the build service in the build cluster builds the change the source, creates a new image, pushes it into the image registry, and creates a new branch in GitHub. So the new branch contains a changed delivery YAML file with a new image address. The run cluster triggers this information in delivery YAML file like this way. This way. The image location here, and then the new branch contains changed delivery file with a new image address. The run cluster triggers this information in delivery YAML file, and then creates a new container with a changed image. By adding an approval mechanism for application deployment, you can deploy applications to multiple clusters in a consistent and secure process like this way. Let's check the simple demo YAML simple demo application. So it is successfully delivered done. Yes, deployed successfully. So you can control the deployment of the workload like this way. Finally, let's look at how security policies can be enforced for the various cluster environments deployed in this way. When applying security policies to multiple Kubernetes, you may be able to apply the policies individually if it is one or two clusters. However, when the number of clusters to be managed increases, management becomes complicated and visibility decreases. I'm going to introduce a solution that can help you solve this problem. It is a solution that is widely used with Tanzu application platform, which we are talking about today, is a solution called Tanzu Mission Control, in short, TMC. Since I'm not going to cover Tanzu Mission Control mainly, I will mention it briefly. Tanzu Mission Control is one of VMware's Tanzu products, and it is a solution that manages Kubernetes in multi-cloud and multi-cluster environment. You can register a list of Kubernetes clusters to be managed and view them at a glance. And there is a screen where you can see at a glance which cloud environment it is installed in, what version it is, resource usages, and current used cluster status. Of course, you can create these clusters yourself here, or you can attach clusters you already have, like this way. Create cluster or attach cluster. Here, there is a screen where you can manage Kubernetes cluster, Kubernetes policies, like this way. So you can manage not only security policies, but also policies such as images, networks, and Quora's custom. You can even add custom policies. If you go to the security tab, there is a cluster group appears like this way, which is a group of multiple clusters. You can apply security policies in units of cluster groups in this way. If you click the Create Security Policy button, you can apply strict baseline and custom policies. Here you can set the policy for the paths. Strict means strict policy. Baseline means predefined security base template. They can apply a basic policy. And you can also set policies that suit your taste by choosing custom. I'm gonna add custom policy like this way, named my DSG policy like this way. Predefined policies such as a baseline and stricter about whether to allow host networks, whether to allow host namespaces sharing, whether to give root privileges to paths, whether to allow volumes, etc. If we want to apply policy to a specific namespace, you can use a label selector here. Here. So, and then, but it is optional. I will do not set it. So, and then click the Create button, like this way. And as you've seen, Tanzu Mission Control can manage Kubernetes on multi-clusters and multi-clouds in a single view. So for example, my policy is applied to all of my clusters here. So for example, long cluster 2, iterate cluster. It is all clusters are applied to my policies, security policies. In addition, you can manage various policies, including multiple security policies of 100 Kubernetes in a single view. This affects better as the number of Kubernetes increases. And finally, Tanzu application platform we talked about can also be installed and managed here. This management has the advantage of being able to manage the life cycle of Tanzu application platform, such as installation, deletion, upgrade, or monitoring. You can see the box of Tanzu application platform like this way. You can just click and configure some of configurations, and you can install in on the cluster. So in short, Tanzu application platform can solve these security issues that may occur in the process of developing and deploying applications. And Tanzu Mission Control can be additionally used to manage various policies if there are a large number of clusters to manage. I've covered everything I wanted to talk about today, and please contact me if you have any questions. Thank you for watching.